Okay, so we're going to talk about perpendicular lines. Perpendicular lines meet to make a right angle or 90-degree angle. And I think you've seen that word before. I'm not sure you've seen the symbol before. That's where you have two segments that make a 90-degree angle. That would be the symbol for perpendicular. I put a couple of lines up here. I brought my trusty, or what this is, protractor. Let's see if these two lines actually are perpendicular. We've got, you probably can't see it, but in fact we do have a 90-degree angle there, so it's a right angle. But there's lots of other perpendicular lines. We've got a line, the crack in the blackboard, in the bottom of the blackboard, at the top with the crack, not to mention the ceiling, and other ones in the room you're in, you can see perpendicular lines. So they meet to form 90-degree right angles. Perpendicular lines, like all the other lines out there on a graph, have slope. The ones I drew, let's see what the slope is. Our rise is 1, 2, 3, 1, 2, 3, 4, 5. So the slope of that line is up 3 over 5. The slope of the other line, let's count from here, 1, 2, 3, 4, 5, 1, 2, 3, but this one's going down. So that slope is negative 5, there it is, negative 5, positive 3, so negative 5/3. Now, I'm sure you noticed this. We've got a 3 and a 5, a 5 and a 3. It turns out this will always happen with perpendicular lines slopes. You're going to have the same numbers. 3/5 is going to be perpendicular to negative 5/3. They're turned over, so they're reciprocals. And I bet you noticed something else. Can you see this? It's one of them's positive and one of them's negative. So we say that they have negative reciprocal slopes for perpendicular lines. Another way to check that the slopes are perpendicular, we want to check and make sure that our two numbers are perpendiculars. We multiply them together. So the product of slopes, here comes that symbol, perpendicular lines, is, let's find out. Let's multiply 3/5 and negative 5/3 and find out what happens. 3/5 times negative 5/3. Multiply across the top, multiply across the bottom. That'll reduce to negative 1. And this will always happen. It's always negative 1 with one set of exceptions. Do you know what those are? Those are going to be when the slope is undefined. You can't have the product of an undefined number and something else. So this rule doesn't work there. It's the only exception. Otherwise, any perpendicular lines, they're going to be, make the product of the slopes will be negative 1. So let's look at what happens in an equation. Without graphing them, we can predict whether the lines are going to be parallel, perpendicular, or neither. Parallel, perpendicular, or neither. You did parallel lines before, I think, so let's try a sample. Y equals 3x plus 4 and y equals 5 plus 3x. Did I forget something? We've got two equations. The slope of this equation is 3. We drew that, the slope would be 3. We did this, the slope would also be 3. It's the same slope, so hopefully you remember that's parallel. Same slope means they're parallel. Let's do another one. I know, we just used that one. What about this? Are those, what do we have with those? We have a slope, the first one, the slope is 3. This one, the slope is -3. These are neither. Just because it's negative doesn't mean that it's perpendicular. It has to be negative and reciprocal. If we multiply those two together, 3 times -3, we wouldn't get -1. We'd get -9, so it doesn't work. Let's try another one. One half x plus 8, 8's your y-intercept, 1/2 is the slope. Here, they're switched around, but 5 is your y-intercept, -2 is your slope. So the slope is 1/2, the slope is -2. Remember, -2 is the same as -2/1. If you invert those, you take the reciprocal, you will have that rule. This is the negative reciprocal of that. Do our check. Here's our check. Does 1/2 times -2/1 equal -1? Yes, it does. So they are, in fact, perpendicular. Shall we do one more example? One more example. Y equals 2/3 x minus 8 and what? Whoa, 3x minus 2y plus equals 16. All right. Now, this one, 8, -8 is the y-intercept and 2/3 is the slope, but 3 is not the slope here, don't forget. We have to do a lot of work to get this in a shape that we can figure out what the slope is just by looking at the equation. We have to get y alone. Don't forget that part. So we'll add our 2y. That way we won't have a -y to work with. We have 3x equals 16 plus 2y. Subtract the 16. Now, let's get that y alone finally. We'll divide everything by 2. So we'll have 3/2 times x. 16 divided by 2 is 8 equals y. Okay, now we've got one equation here. Y-intercept is -8, the slope is 2/3. This one Now, 2/3 and 3/2, I'm sorry, 2/3 and 3/2 are reciprocals, but they're both positive. These will not turn out to be perpendicular. We can check it with the check. 6/6 equals 1, not -1. So these guys are, in fact, not perpendicular. Now I think it's worth looking at for real quick on the graph paper to see what, they don't even look perpendicular if you graph them. Okay, you're going to wonder what this is. This is a big piece of plastic with holes in it. I'm going to put dust, run over it with dust, and it'll make graph paper. It's called a dust graph. So here we've got just real quick, I want to compare. Here's our x, here's our y, here's our x. Let's do a slope of 3/2 and then a slope of 2/3, just so you can see that they don't even look perpendicular. So 3/2, up 3/2, up 3/2. We've got a few of those guys. Here's that line. That one's 3/2. Here comes up 2/3, up 2/3, up 2/3. The numbers are the same, but no one, I don't think anyone, would say, if I got my protractor up off the floor and measured this, it's not going to be 90 degrees. You can see visually here, these are still not perpendicular. There's one trick problem you want me to do? That trick problem with A in it? We could do that. So we're going to do a little problem where we're going to find A if 1/4 x, that line is perpendicular to y equals 7a minus 10x. And I think this one was -1/4 when we made that. So y equals -1/4 x is perpendicular to y equals 7a minus 10 times x. Pretty complicated, but we can do it. Perpendicular to -1/4, that slope it's perpendicular to a slope of positive 4/1. Reciprocal and make it negative. That one was negative, now it's positive. Now we're going to set our 4 equal to 7a minus 10. That's going to be our new slope. Add 10. Divide by 7. And right on the very bottom of the blackboard, we have a equals 2. And that's just one little trick problem. We're gonna do more with this, lots more, I promise.